class, this is Coach Riza. For today, we are going to talk about minerals and rocks. Last time, we talked about the Earth and its subsystem, the interaction of each spheres, and the cause and effect of an event to our spheres. Now, we are going to talk about the importance of minerals to our planet Earth and how rocks are formed. Minerals and rocks are the significant building blocks of our dynamic Earth. They make up the solid part of lithosphere and provide us with valuable resources. More than 4,000 minerals identified by scientists, but only few occur as rock-forming minerals. So here's an example of our minerals. So these are some of the few minerals that we know. At nakikita natin siya usually sa ating mga jewelries and sa mga charms, yes, bracelets, charms, and yun nga, sa mga naniniwala sa feng shui, ayan. So, yun usually yung ginagamit na items, no, for bringing good luck, the minerals. So, what are minerals? So, a mineral is naturally occurring, inorganic, homogeneous solid with definite chemical composition and ordered internal crystalline structure. So basically, minerals are building blocks of rocks. So we have 5 main criteria of minerals. So let's find out. So number 1, it's naturally occurring, meaning it is made by natural process and not made by artificial means. Second, it's inorganic. It is made without aid and once part of any organism, like bones, shells, or teeth. Third is homogeneous. So it's a homogeneous solid, meaning to say it has a uniform appearance or it's in uniform appearance. So it is in solid state of matter. Fourth is chemical composition. So it has a definite mineral constituents. For example, we have pyrites. And pyrite has a uniform chemical composition in ratio of iron sulfide. So all of our minerals have different chemical compositions, and of course it varies depending on what type of mineral it is. Okay, so fifth is ordered internal or crystalline structure. So elemental components are arranged in an ordered fashion, repeats a three-dimensional framework and ordered atomic arrangement. So it's within the material, it's the elemental components, the atoms within our minerals are in ordered or has a orderly uniform arrangement, or so it has a uniform arrangement, ordered internal crystalline structure. Okay, and we can only see that using a special type of microscope to see the structure of our minerals. Okay, so do these minerals are like each other or have the same color or hardness? So what do you think, class? Are they the same? Do they look the same? Okay, so let's find out. So our minerals has what we call the physical properties. Now every type of minerals has different physical properties. And here are the physical properties of our minerals. So minerals have different properties. So when we say property, it's a character that describes something. And the first property that we're going to talk about is the color. It's in British spelling, but color, the same. In US, it's COLOR. In British, it's COLOUR. Anyways, it's color. So, as you can see, we have 2 minerals here. We have talc and topaz. And they both have a different color. Okay, as you can see, talc is in white color, while the topaz is in blue color. So from that we can see already that they are both different based from their appearance, which is the color. So we can differentiate each minerals by its color. So color, it is the perceived wavelength of light that bounces off from the material and is detected by our eyes. So colors varies depends on the mineral's composition. Minerals have the same chemical composition but small variation of the quantity and distribution of some elements will give the same mineral different colors. So like what we have a while ago, talc and topaz, they're both different. They have different compositions within. So they have different chemical compositions. That's why it gives a different color. Okay, so talc is white and topaz is blue. But we have another case here wherein they are both, or they are all, each examples are all quartz, but they have different color. So as I have explained a while ago, it depends on the chemical composition within our material or mineral. So for this case, these are all quartz, but there are certain part of their chemical composition that causes this different color for each quartz. Okay, so it depends again on the element or the distribution of some elements or the chemical composition, but it's still the same. These are all examples of quartz in different colors. Okay, second is hardness. So another physical properties to take note to for our minerals is hardness. So hardness is the mineral's ability to scratch another mineral or be scratched by another mineral. Hardness, it is the resistance of a mineral from scratching. We can say that it is hard if it can resist another mineral from scratching it. Okay? In determining hardness, the mineral is tested by scratching the surface with measurable amount of force. So usually minimum force. Okay? So in finding the hardness, now we have this what we call Mohs scale or the hardness scale. It's in 1 to 10. It's from increasing hardness from 1 to 10. Of course, 1 is the lowest and the 10 is the highest or the hardest. As you can see based on our examples, we have here our minerals, examples of minerals under the Mohs scale or Mohs hardness scale, and then the common objects that could scratch that mineral. Okay, on the other side, we can see the different types of objects that could scratch the mineral. From that, we can test the hardness now using these different common objects or minerals. Okay, so here, as you can see, the descriptions from 1 to 10. From 1, it's very soft, so it's easily crumbles, so it can be scratched by with a fingernail. So it's talc. Okay, so the rest, first 1 to 3 is soft, 4 is semi-hard, 5 to 6 is hard, 7 is very hard, 7 and 8 is very hard, 9 is extremely hard, and the hardest of them all is diamond. Okay, so diamond is used to cut all the minerals. Okay, so here is the hardness test. So as I have said, hardness can be tested if two objects, a mineral or another object or mineral to mineral, scratched to each other to test if it could resist or not the scratching of another material. So here it is. We have mineral on mineral. It can be a fingernail or another object like penny, knife, file, glass, or yes, to test it on a tile to know the hardness of our minerals. So it's usually used by our scientists in determining the hardness tests. So the archaeologists, those who work at the mines, they test the hardness of the minerals. So the scale of minerals, which is the Mohs scale, can be used like this. Okay, so how do we apply this? So knowing that we have our Mohs scale, it's from 1 to 10, we can determine which minerals can scratch another mineral and vice versa. Okay, so let's have here an example question. So which mineral will scratch topaz? So kindly think of which of these from our Mohs scale can scratch a topaz. Topaz is number 8. So which number from our Mohs scale can scratch topaz? Okay, so you have an answer. So it's 9 and 10. Okay, so of course 9 and 10 is the hardest than topaz. So it can scratch topaz. Okay, so number 2. Which mineral scratch diamond? Okay, as I have mentioned a while ago, diamond can scratch all the minerals. So which one can scratch, or which mineral out of this 1 to 10 scale can scratch our diamond? The answer is itself. Of course, diamond can scratch itself. Diamond to diamond can scratch each other because it's the hardest among all the minerals in our Mohs scale. Next is, which minerals does diamond scratch? The answer is, of course, 1 to 10. Yeah, so that is correct. If your answer is 1 to 10, then you are correct. So diamond, as I have said, can scratch all the minerals. Last question is, which mineral does talc scratch? Okay, none. It can be none, it can be itself. Because talc, again, is very soft. It's very brittle. It can easily crumble into smaller pieces. Okay, so that's how very soft our talc is. So just to give you an idea, talc is one of the main ingredients for our powders. Okay, so if you love makeup or you like powders, yeah, pressed powders, baby powders, or you use that cosmetics. So it's one of the main ingredients of our cosmetics, which is talc. So next property of mineral, physical property, is streak. Streak is when you scratch mineral along a white tile and it leaves a powder. So streak is the color of that powder. So the streak can be different from the mineral color. So it depends again on our minerals. So as I have said, minerals have different compositions and different color. And another property which could show the difference when it comes to the color of streak is this one. The powder that is left when it's scratched in another surface. So from that, we can differentiate our minerals by its color. So that is our streak. Okay, so again, it varies depending on the mineral's composition and color. Next is luster. So luster, it is the behavior of light as it is reflected by the surface of a mineral. It can be metallic or non-metallic. So metallic luster is that it reflects light similar to a polished metal. So we have there an example, galena. It's a mineral and it looks metallic. Next is non-metallic, which is pearly or waxy versus silky. So we have examples like calcite and quartz. So as you can see, it's non-metallic. It's not like metals or shiny as metal. So that's why it's under the non-metallic. So again, examples of lusters, we have luster, the property of mineral luster. We have shiny, we have glassy, we have pearly, and we have a dull or lackluster. So there are minerals that doesn't have luster. Okay, like this one. It's dull. It doesn't have shine. Okay, so next is cleavage. So cleavage is the tendency of mineral to break along particular directions. So the breakage happens along zones of weakness within the crystal structure of the mineral. So our minerals has different structures. They have different appearance. So as you can see in our example, we have here different types of minerals. And they have different type of structure. Here we can see that some areas have weak zones na tinatawag. Those are cleavage. Kumbaga, yun yung mga part na madaling ma-break from our mineral. There are parts of our minerals that has weak areas which can easily break from our mineral. So that's what we call cleavage. Okay, so those are the physical properties of minerals. So first we have the color, the hardness, the streak, luster, and the cleavage. Next is the chemical properties of minerals. As I have told you, minerals varies depending on its chemical composition. So now let's see what type of chemical properties do our minerals have and paano ba sila nadidistinguish or nagugrupo from that certain chemical properties or chemical groups. So let's find out. First is the silicates. So silicates are minerals containing two of the most abundant elements in the Earth's crust, which is the silicon and the oxygen. So linked together to form silicon-oxygen tetrahedron, fundamental building block of silicate minerals. So 90% of rock-forming minerals belong to this group. So imagine, these are two of the most abundant elements of our Earth's crust. And 90% of the rock-forming minerals na natatagpuan sa ating Earth's crust belongs to this group. Okay, so this is our first group of chemical group, which is silicates. So what are the examples of silicates? We have here feldspar, olivine, quartz, mica, pyroxene. So these are just a few examples of silicate minerals. Okay, so of course, as I have said, minerals are usually used for accessories, construction. Minerals also is used for as raw materials for other products. Like for example, we have here mica. So to give you an idea, mica is used for cosmetics. So mica has a very lustrous, very shiny type of mineral. So mica is used sa cosmetics. Yan. So girls, your eyeshadows contains mica. Okay, so one of the key ingredients for eyeshadows, shimmers, and yeah, shiny, shimmery makeups. So it contains mica. So those are silicate minerals, or examples of silicate minerals. Next is oxides. So formed from the combination of a metal with oxygen. So minerals containing oxygen and ion combined in one or more metal ions. And third is sulfates. So minerals containing sulfur and oxygen and ion. So that's the chemical formula combined with other ions. So let's find out what are these oxides and sulfates. Here it is. So oxide minerals we have here. As you can see, the chemical formula is given. So we have there iron 2 oxide, iron 3 oxide, aluminum oxide. So we can see already that it is under the oxide minerals because of its chemical composition. So that's how they use the chemical properties of our minerals in determining our different types of mineral. We can see it once it is tested. We can see the chemical composition. And from that, we can group it. We can already identify from which group of chemical properties it belongs. So for here, we have oxides. So oxide minerals. But we're not going to memorize this. Don't worry, class. We are not going to memorize chemical compositions. It's just to give you an idea of what is the chemical properties of our minerals. And from that, we can determine from which group does it belong, and we can differentiate them from each other. So again, minerals are different in many ways, and one of those ways is the physical properties and of course the chemical properties. So from the chemical properties, we can see their differences by their chemical composition. Okay? So next is sulfides. So minerals containing sulfur and ion with one or more ions. And carbonates, minerals containing carbonate and ion combined with other elements. So here it is. Okay? As you can see, it's the sulfide minerals. Ayan, very lustrous sila, very shiny, metal-like ang luster nila. Okay? Next is the carbonate minerals. So we have there, as you can see, the carbonate. Okay, so we have there the carbonate minerals. Okay, so we have there calcite, dolomite, azurite, malachite, and so those are carbonate minerals. Next is phosphates and halides. So phosphates muna. Next is phosphates. Minerals containing phosphorus and oxygen in 1:4 ratio. And halides, which is minerals containing halogen elements combined with one or more elements. So what are those halogen elements? We have their chlorine, fluorine, and so on. So dun sa table natin, sa periodic table, we can see the halogens. Okay, so first we have phosphate minerals. So here is an example of phosphate minerals. So we have apatite and turquoise. Ito pala yung itsura ng turquoise kapag bagong mina pa lang, no? Hindi pa siya yung napaprocess into the jewelries that we know, no? Yung nakikita natin, no? Yung shiny na siya. So ito yung itsura nila kapag bagong mina or galing sa minahan. So next is halide minerals. So we have there halides, okay? Halide minerals. Last but not the least is the native elements. Ayan. So minerals that form as individual elements, they are with high thermal and electrical conductivity. So example is gold and lead. Lower conductivity, arsenic, bismuth, and non-metals such as diamonds. Okay, so as you can see, we have their gold, copper, silver, sulfur. So they are all native elements. Okay, they are minerals, but they're also elements. So those are the chemical properties of our minerals. Uses of minerals. So, para saan ba itong mga minerals na to? Ano bang uses nila? So, first is construction. Of course, very important yan sa construction industry. So, jewelry industry. So, na nakukuha yung mga gems natin, gemstones. Ayan, yung mga crystal na yan na ginagamit sa feng shui. Ayan, ginagamit yung ating mga minerals. Sabi ko nga, construction, sa computer chips, ayan, may kita tayo mga minerals dyan. Clocks and watches. So, those are the uses of minerals. So, next, let's move on to our rocks. Okay, so rocks are a mixture of minerals, volcanic glass, organic matter, or other materials. Aggregates of one or more minerals. So, pinagsama-sama ito, no, na minerals, different types of minerals, for volcanic glass, organic matter, and other materials na natatagpuan sa Earth's crust, na bumubuo sa ating rocks. Okay. So, here's an example of a rock. It's a granite. It's an intrusive igneous rock. We can see the different types of minerals within our igneous rock. We have there our quartz, hornblende, and feldspar mixed together into one rock. And that is our granite. So, yun po yung example ng ating rocks. Okay. But there are three types of rocks. Like we have encountered it last time that there are three types of rocks. So now we're going to talk about these three types of rocks and the processes that it undergone to form that rocks. So first is the igneous rock. So derived from the Latin word ignis, meaning fire. So igneous rock. Igneous rock is associated with volcanic activity and are also called magmatic rock. So igneous rocks are characterized by where they are formed and their grains. So these rocks are molded by the cooling of magma below the surface or lava above the surface. Igneous rocks are formed from these two. We have the magma and the lava. So again, magma is the molten rock beneath the Earth's surface, while lava is the molten rock material extruded on the Earth's surface. So basically, yung magma na nilabas from our volcan became lava. Okay, naiba na yung pangalan niya kapag nakalabas na. Kapag nasa loob, magma ang tawag. Kapag nasa labas na, lava na ang tawag. And from this material, from this origin, nabubuo yung ating igneous rocks. So, paano siya nabubuo? Kapag ito ay nag-cool down at nag-solidify. Okay? So, we have two types of igneous rocks. We have first the plutonic or intrusive igneous rocks. So what is this? It is when a molten material solidifies below the surface of the Earth, cooling slowly resulting to form large crystals. So basically, our intrusive or plutonic igneous rocks came from our magma. So the magma within our Earth that cools and solidify, forming this intrusive igneous rocks. Next is our volcanic. Next type is the volcanic or extrusive igneous rock. So it is when a molten material solidifies at the surface of the Earth, cooling fast to form small crystals. So basically, its origin is the lava. The lava that was extruded on the surface of the Earth, and it cools down and solidifies, forming this extrusive or volcanic igneous rocks. Igneous rocks. So those are the two types of igneous rocks. We have the intrusive or plutonic igneous rocks and the volcanic or extrusive igneous rocks. Igneous rocks are also classified according to the silica content. So as I have said way back from our chemical composition, if you could still remember, that silica content is very high in our minerals. 90% of the rock-forming minerals has silica content. First, we have felsic, also called as granitic. So these are rocks that contains greater than 65% silica and are generally light colored. Second is intermediate, also called as andesitic, rocks that contains 55 to 65% silica, so generally medium in color. Mafic is the third one. It's also called basaltic, contains 45 to 55% silica, generally dark in color. And then last is the ultramafic, which is less than 45% silica and it's very dark in color, composed mainly of olivine and pyroxene, which are the major constituents of the upper mantle. So let's see what are these classification of our igneous rocks based or according to the silica content. So we have here an example. Okay, so we have here the felsic, intermediate, and mafic for both extrusive and intrusive igneous rocks. So as you can see, felsic is very light colored, meaning to say it has higher content of or percentage of the silica content. We have intermediate, medyo medium, intermediate lang din yung color niya. And we have mafic, so this has a lesser silica percentage or silica content, so it's darker in color. So from that, now we can identify based from the color the percentage or the content of our silica content. So next type of rock is a sedimentary rock. So these rocks are formed by the deposition of materials on the Earth's surface at low temperature and pressure. So these are made up of dissolved particles or sediments of previously existing rocks. So let's find out how sedimentary rocks are formed. So the sedimentary rocks undergoes the sedimentary process. So it composed of weathering, erosion, sedimentation, deposition, compaction, and cementation. So it's a very long process on how our sedimentary rocks are formed. So let's find out. So first is weathering. So when a rock is broken down into smaller pieces by wind, ice, rain, or moving water, it is called weathering. So the continuous exposure of these rocks from different types of weathers, sun, rain, ice, snow, even the water, the rush of water. So it causes our rocks to be broken down into smaller pieces. Okay? And it's a long process. It takes years for it, of course, to be broken down into smaller pieces. So when the pieces of rocks are carried away, it is called erosions. So, of course, we have the broken or smaller pieces of rocks. And then when there is, of course, flash flood or erosion, soil erosion, so it can be carried away. And from that, it will deposit usually on our bodies of water. So sedimentation includes processes that causes minerals and organic particles to settle and accumulate, or minerals to precipitate from a solution. So for our case, it's the bodies of water. So a tendency is that the sediments, which can be a pieces of rock, minerals, or bit of plants or shells, deposits and accumulate under our bodies of water. So that is the sedimentation part, or the sedimentation process. So when rocks are settled to the bottom, so the rocks are deposited. So layers of sediments are pressed and compacted and cemented together. So again, it's years of exposure to weathering, soil erosion, sedimentation, deposition, compaction, and then cementation. So it's years for it to form into these layers of sediments. As you can see, we have here, this is already a mountain range of sedimentary rocks. So as you can see the layers. So how many years does it take for the sedimentary rocks to be formed? As I have said, it's millions of years for it to form like this way. Okay, so as I have said, it is usually found near the bodies of water, like rivers, riversides, lakes, even the ocean beds. Okay, so it is formed under our bodies of water. So it takes millions of years, continuous process of weathering, soil erosion, deposition, sedimentation, compaction, and cementation to form our sedimentary rocks. So here is our sedimentary rocks. These are examples. We have limestone, chalk, shale. So imagine chalk is a sedimentary rock, which we usually use on our blackboards now as a writing tool. So those are the sedimentary rocks. Sedimentary rocks may be divided into three categories. First, we have clastic or detrital. So it's composed of solid products of weathering. So gravel, sand, silt, and clay cemented together by the dissolved weathering products, forming this clastic sedimentary rocks. Next is biogenic or biochemical. So it's composed of materials formed by the activity of living organisms. So biogenic sediments contain fossils. If the remains are broken and scattered, it is bioclastic sediment. So as you can see, the rocks, as you can see, the rocks from our pictures contains fossils, bits of shells, as you can see there. So these are under the biogenic or biochemical sedimentary rock. Next is chemically precipitated or chemical sedimentary rocks. So these rocks are those such as halite or gypsum and some limestones, which form direct precipitation. So it means to say that from a solution, it precipitated into what it is now. So from a solution, it precipitated into the chemical sedimentary rock. So examples of these are gypsum, travertine, chert, and rock salt. So as you can see, an example of this are rock salt. Okay, from a salty water forms our rock salts. If you can still remember the area somewhere in Valletta, there was once a salt producing area there where the salts are being produced by our salt water. And so pag nainitan, natutuyo siya doon sa bed, okay, sa mababaw na part nung katubigan doon sa Noveleta part area there. And from there, nagpo-form yung mga salt. Okay? So that's how it chemically precipitate. Dahil sa init ng araw, nawawala yung liquid form ng solution. Ang natitira yung mapiprecipitate yung solid form or solid part. And then forming the salt or the rock. So chemically precipitated or sedimentary rock. Next type of rock is the metamorphic rock. So metamorphic rocks are results of transformation of a pre-existing rock in the process called metamorphism. So metamorphism came from the Greek words meta, which means change, and morphe, which means form. So, metamorphic rock. So, paano ba ito nabubuo? So, we have here a question. Temperature below the Earth's surface is high or low? So, paano ba dapat ang temperature natin below the Earth's surface? High or low? The pressure below the Earth's surface, it should be high or low? So, the answer is high. Ayan. So, dapat mataas yung temperatura, no? Hindi mafo-form ang ating metamorphic rock kung hindi mataas ang temperatura sa ating Earth's or below the Earth's surface. The pressure also must be high for it to metamorphosize. So, metamorphic rocks are formed from other rocks by extreme heat and pressure. Question: is it formed below Earth's surface or above? It is formed below. Okay? So, it's formed below the Earth's surface. So, ano ba yung tsura neto? Here it is. So, metamorphic rock. So, paano ba nag-metamorphosize ang ating mga pre-existing rocks? So, ito ay nabubuo na metamorphic rocks are formed due to the extreme heat and pressure. Ayan. So, nasa gitna yung ating mga rocks dyan. Okay? And then, due to the extreme heat and pressure, okay, nabubuo ang ating metamorphic rock. So, metamorphic rock. So, we have here examples. So, from a pre-existing rock, we have igneous rock. Undergone heat and pressure, naging metamorphic. So, ayan, from granite to gneiss. So, metamorphic rock. The minerals get rearranged and pressed into thin layers, and these layers are called bands. So, bands may be straight or wavy. As you can see from our example, we have here layers. We can see the layers on our metamorphic rocks. So, some metamorphic rocks now have these layers or bands na tinatawag. So, other examples of metamorphic rocks, we have limestone, turned to marble. It's a sedimentary rock, turned into metamorphic rock. Another sedimentary rock, sandstone, turned into quartzite. So, metamorphic rock na siya. Shale to slate. Shale to slate. Ayan. So, usually, these rocks are used for construction as construction material. So, yun yung mga nakikita natin sa mga tiles natin. Ayan. So, the metamorphic rocks. So, here is the rock cycle. We have encountered it last time, right? So, let's see. How is this rock cycle? So, first, now we start from our magma and our lava. As it cools, now it forms into our igneous rock. So, the igneous rock, once subjected to weathering and erosion, it will be broken and turned into sediments. So, the sediments, once pressed and cemented, will turn into sedimentary rocks. Our sedimentary rocks, once subjected to heat and pressure, will turn into metamorphic rock. And when our metamorphic rock is heated to melting, it will turn back into magma. Okay. Moving to our igneous rock, so ganun din, if it melts, it will turn back into magma. If it's subjected to heat and pressure, it will turn to metamorphic rock. Our metamorphic rock, when subjected to weathering and erosion, can turn to sediments, and then sediments pressed and cemented will turn into sedimentary rock. So as you can see, it's a cycle, no? Nare-recycle lang yung different types of rocks natin. Okay, so depende sa proseso na pinagdaanan niya, yung magiging outcome no ating mga rocks. So that is our rock cycle. So uses of rocks. There are a lot of uses no, of our rocks and different types of rocks. So here are some of the examples. We have here granite. So it is hard. It's impermeable. So we have here, no? So granite is usually used as construction materials for tiles, as tiles. Ayan. So pumice, it has a rough texture and it is used to make soap, hand soap. Chalk, formed from the skeletons of tiny sea animals, used to make chalk. Chalk din ang pangalan niya. No? We use this to write on our blackboards. Shale is usually used to make bricks and pottery. Slate is usually used for roofing tiles and billiard tables. We have here marble, which is usually used to make tiles, and statues. So those are the uses of some of the uses of our rocks. So that is our topic for today, the minerals and the rock. Is everything clear? Any questions? If you have any questions, just PM me via Messenger or via LMS chat box. Thank you for listening. I hope you've learned a lot. Reminders, read and review our lesson, watch all video links, answer all activities. It's all posted at Module 2, so please do this during your asynchronous schedule for ELS. Again, thank you and hope to see you in our next class. Bye!